Hello, Geometry, ELL. We are here in Chapter 11, finishing Target 2 and also looking at Target 4. Not sure how much time you spend reading the targets, but there is one word missing from Target 2, and that's the goal of today, at least the first half, is to talk about spheres. Before we do that, there's a little warm-up. These are actually Chapter 10 questions. If you want to pause the video and try those, you can. If not, just sit back and enjoy the ride. What I maybe should do is review our formulas from Chapter 10. We know that area of a circle is pi times radius squared. We know that circumference equals 2 times pi times radius. Sometimes we use the formula circumference equals pi times diameter. So if we jump into warm-up problem number 1, find the radius of a circle if the diameter is 32. So maybe I'm going to use my formula, C equals pi d. And in this case, actually that's not even necessary. That's so funny. I don't know. I was ready for the harder problems. And just a review, that the radius is half of the diameter. So the radius is 32 divided by 2 is 16. And if you're asked for units, the radius is a length. So we'll stop at centimeters. All right. And now number 2 is saying find the circumference if we know the radius. So this would be a good time to use the formula C equals 2 pi r. So circumference equals 2 times pi times the big radius, 42.5. And so 42.5 times 2 is 85. And I would stop at 85 pi. Circumference is also just a length, so we would say just meters. You could give a decimal for 85 pi, but it takes too long, so we don't need to. Find the area of a circle with a diameter of 26 feet. So here we go. If the diameter is 26, that means that the radius is half of 26 is 13. And now we can use the formula area equals pi times radius squared. And so we have 13 squared. So we have 169 pi. And this one is an area, so that would be square feet. And let's go Glenbard Green. Find the circumference if the area is 81 pi. So this was another Chapter 10 question. So before I can find the circumference, I need the radius, but I'm going to have to use my area formula to find that radius. So 81 pi equals pi times radius squared. So we can divide both sides by pi. Say bye-bye to the pi. And so radius squared equals 81. So we will take the square root of 81 to get the radius of 9. And now I can use my formula. Circumference equals 2 pi r. So 2 times pi times 9. So 18 pi. And circumference is a length, so that would just be inches. All right, so that was all two-dimensional, but now it's time to go three-dimensional and look at these amazing spheres. So a sphere is the set of all points that are a given distance, and that distance we call the radius. And that's already labeled here on the picture. I'll color it in blue. There's the radius. So if you start at that center point, so I guess I should add that too. There's the center. So any point the same distance away from that center in any direction would form the beautiful, perfect sphere. Now another vocab word is the great circle. Best way to think about a great circle is think about the equator. So it's the intersection of a plane passing through the center of a sphere. So think about this guy right here. So that's a circle. So that's how we get to use our Chapter 10 formulas dealing with circles. So that's called the great circle. It's the biggest circle that you could draw on a sphere. And again, I just think of it as the equator on the Earth. And another good vocab word is if you cut a sphere in half, you get 2 hemispheres. Hemispheres. And then that we said that right here. A hemisphere is half of a sphere. Okay, so there is only one formula for a sphere. There's no such thing as a lateral surface area. The sphere is the sphere, and the surface is the entire outside of that sphere. That's all we can do. And so our formula for total surface area, usually I remember I just write T or TA, but some people write TSA, and that is 4 pi r squared. So we'll take a look at 2 pictures, and then we'll take a break, and then we'll finish these exciting notes. Thanks for being here today. All right, so first one, maybe it's a beach ball. Wouldn't it be nice if it was summer vacation and we were all on the beach? So total surface area equals 4 pi r squared, but this time they gave us a diameter, so you don't necessarily have to do this in the picture, but half of 50 is 25. This is going to be huge. Holy moly. So that's 25 squared is 625 times 4, 2,500 pi. And this is an area, so that's centimeters squared. Again, you could give a decimal. Let's not spend time pressing buttons on a calculator, but you could give a decimal if you needed it. Now, this hemisphere is a little bit interesting. We want the total surface area. Maybe this is your art. Well, I would like to make this your art project, but 15 meters is too big, so I don't even know what we're going to call this one here. So what we do have, though, I'm going to use 2 different colors. So we do have a hemisphere. All right, and that's going to take care of all of this area. But take a look. Remember, this is a solid object, so we also have this top surface here, which is a circle. So we're going to do hemisphere plus circle. So the hemisphere is half of a sphere, so it's half 4 pi r squared, which is also just 2 pi r squared. And then our circle, you know from chapter 10, and the warm-up is pi r squared. Now, interesting thing, if you want to do it this way, you could just go and put the numbers in right now, but if you wanted to, half of 4 is 2, and it turns out that these get to add together. So 1 pi r squared plus 2 pi r squared, we can actually do, 3 pi r squared if you want to. So usually I just keep them separate, but I wanted you guys to see that you could do that. So 3 times pi, 15 was the radius that they gave us. And so we have 15 squared is 225 times the 3, 675 pi, and this is area, so that's meters squared. All right, I hope you're having a good time. I'll see you in a little bit with the next video. Bye-bye.